Hey there, data enthusiasts. How are you? Welcome back to our ML adventure. Today we are diving into what I consider the secret sauce of machine learning, feature engineering as outlined in Task Statement 2.2 from the AWS Certified Machine Learning Specialty Exam Guide. So, why am I so pumped about feature engineering? Because this is where we transform from data scientist into data artist. You start with raw, messy data. Think of it like finding random Lego pieces scattered across the floor and meticulously craft them into an amazing structure your model can actually use, right? So, great feature engineering can turn a mediocre model into a rock star performer. So, in the ML world, right, feature engineering is all about discovering hidden gems in raw data, transforming these gems into polished features, right? And then testing whether your shiny new features actually help your model or just add, unnecessary bling. Ready to make your data sparkle? Let's roll up your sleeves and get our hands dirty. All right, so text data. Text is, of course, everywhere, right? From your ex's cryptic tweets to your grandma's email forwards. But how do we turn human language into something a computer can work with, right? First is tokenization, chopping sentences into bite-sized word. An example would be, feature engineering rocks. So feature engineering rocks. These are three words, right? It's like turning a cake into individual slices. Much easier to handle. And then normalization. That makes text uniform and well-behaved. For example, hello, hello. Think of it as dress code informants for your word, right? So stop word removal, like kicking out freeloading words like the and off that don't pull it their weight. They're like those party guests who show up everywhere but contribute nothing to the conversation. Then you've got stemming, right? Finding word families by reducing them to their roots, right? Example, running, runs, ran, run, right? It's like realizing that your neighbor, your neighbor's cousin, and your neighbor's cousin's remote roommate are all related. Okay. One hot encoding, you'll hear this a lot. So this is a digital equivalent of are you this word? Yes or no. For every word in your for example, small vocabularies like, but gets unwieldy fast, like trying to identify someone by asking, are you a person number one, person number two, or person number three? Right? Word embeddings. Dense vectors capturing semantic relationships, where king dash man plus woman equals queen, right? Actually works. These are the cool kids of NLP, pre-trained and ready to transfer their knowledge to your project. Then you've got TF-IDF, a technique that says common words, right? Boring, rare but present words. Now we're talking it's like a hipster algorithm that values uniqueness. And n-grams, capturing word neighborhoods instead of isolating words, because hot dog means something very different than hot and dog, right? Imagine you're building a sentiment classifier for restaurant reviews. With clever feature engineering, your model could tell the difference between not worth the wait, which is negative, and worth the wait, which is positive, even though they share most words, right? Then moving on to speech data, right? Speech is like text wearing a fancy audio costume. Here's how we undress it, okay? Acoustic features, or MFCC, capturing the spectral envelope, the audio fingerprint of sounds. I think of MFC as capturing not just what was said, but how it was said, right? Then phoneme embeddings, representing sounds in units numerically. Because your hello and my hello might sound different, but they are the same greeting, right? So picture you're a smart speaker trying to figure out if you're asking a question or giving a command. Features like pitch contour and timing help it know whether to get milk is a reminder or a question about whether you have milk. Right. Moving on to image data. So images to humans worth 1,000 words. So computers, just a grid of numbers. Let's bridge the gap, right? So raw pixel values, just using the numbers straight up, simple but unwieldy, like trying to, describe a painting by listing the exact color of each dot. Then you've got edge detection and texture analysis. It's finding boundaries and patterns. It's like focusing on outline of a cat rather than every single whisker. Then you have traditional feature extractors, SIFT or HOG. I mean, this is a veteran techniques that paved the way, right? They're like those experienced co-workers who may not know the latest trends but have rock solid fundamentals. And then CNN features, right? This is where you leverage pre-trained neural networks as feature factories. Why reinvent the wheel when you can borrow Ferrari wheels, right? So if you are tasked with building that millionth cat versus dog classifier, tapping into pre-trained CNN features can save you from training for days, right? It's like having a team of experts who have already stared at millions of animal photos, so you don't have to. All right, public data sets, right? So your data is great, but sometimes it needs more, right? You need more friends. So demographic data, these are census information that adds context to your user data, right? It's like meeting someone new and then learning about their hometown. Suddenly things make more sense, right? Then geospatial data is location, weather, traffic patterns, because sometimes where matters as much as what or who, right? And then you have financial or economic indicators. These are market trends that might influence behavior. The financial equivalent of checking if it's raining before predicting umbrella sales, right? So imagine building a house price predictor. Sure, bedrooms and square footage matter, but what about school ratings or crime stats? By blending your listing data with public data sets, your model becomes a real estate agent who knows not just the house, but the whole neighborhood. All right, so now move to analyzing and evaluating feature engineering concepts, okay? So now that you've gathered potential features like a data prospector, let's separate the gold from the dirt. How do we know which features are treasure and which are just shiny rocks, right? So the core concepts would be binning, or converting continuous values into categorical buckets. Example would be age, child, adult, senior, right? It's like saying, I don't need your exact age. I just need to know which movie rating applies to you, right? So I need to know what age are you. Tokenization strategies. So word level, character level, or subword tokenization each have their place. If you're analyzing text full of OMGs and LOLs, character level might catch patterns that word misses, right? And then outlier handling. Those wild points that throw everything off. They're like that one friend who suggests skydiving during casual coffee planning, right? Sometimes you need to gently exclude them from calculations, right? So what are your options, right? You can remove them, the nuclear option, or transform them. Lock transforms can tame extreme values, or use algorithms resistant to their influence. Then we need to talk about synthetic features, the alchemist approach, creating new features from existing ones, right? So interaction terms will be feature A, feature B. Domain specific combinations, for example, creating BMI for height and weight. This is where domain knowledge shines brighter than technical skills. And then one hot encoding, turning categories into binary features. It's like replacing what color is it with a series of yes, no questions. Is it red? Is it blue? Is it green? Right? Just watch out for the dummy variable trap and dimensional explosion. Your 1,000 product categories don't all need their dimensionality reduction. Man, English is not my first language. There are some words that's really hard for me to pronounce, and this definitely is one of them. Because sometimes less is more. So PCA, finding the directions of maximum variance, like identifying the north, south, and east, west of your data. And then TSNE, great for visualizing complex data in 2D or 3D. It's like creating a map of your high-dimensional data world. And feature selection, purposefully choosing which features stay and which go. Sometimes, that's sometimes the Marie Kondo approach is best, right? Reducing dimensions can speed up training and fight overfitting. It's like, decluttering your data apartment, right? And then evaluation, right? How do you know your feature engineering wizardly actually helped? Let's measure the magic, right? Train and compare. So baseline model, original features, the before picture, right? And then enhanced model should be with your engineered features, the after, the makeover. Now the compare the matrix accuracy, F1 score, RO or RMSC, the data science equivalent of those dramatic makeover reveals, right? And feature importance analysis, use algorithms like XGBoost or random forest that can rank features. And try SHAP values to understand not just which features matter, but how they contribute to each prediction. It's like figuring out which ingredient in your recipe are actually making it delicious. And, last but not the least, A/B testing in production. If possible, test different feature sets or drill users. Because sometimes the proof is in the pudding, or in this case, the production environment. So if your new feature set boosts accuracy by 10%, it's champagne time. It is just 0.1%. Well, that's still thousands of better predictions at a scale. Remember, most models improve through accumulated small gains rather than one dramatic breakthrough. All right, so as we conclude, right, let's start simple, right? That's something that I tell everybody, right? Begin with baseline models before adding bells and whistles. You don't want to add a turbocharger before making sure your car engine runs, right? And then from the exam perspective, the products that you want to remember is Amazon Comprehend, right? Let's let AWS do the heavy NLP lifting, right? Or Amazon Recognition, computer vision without the computer vision PhD, right? Amazon Transcribe, turn audio into text before applying text techniques, right? These services are like having specialized contractors for different parts of your data house renovation. Most importantly, document your journey. Track which transformation you tried, how they affected your matrix, and why you choose certain approaches. Trust me, future you will thank you for leaving these breadcrumbs. And befriend domain experts. It's like medical data, chat with if it's medical data, right? Chat with doctors. Financial data, find a finance guru. Sometimes a 5-minute conversation with an expert can save 5 days of feature engineering experimentation. And my friends, don't go feature crazy. Adding too many features can lead to overfitting or resource drain. It's like adding too many spices to your soup. At some point, you're just making it complicated, not better. Okay. So remember, feature engineering is where science meets art in the machine learning world. You could have the fanciest algorithm on the block, but feed it lousy features, and it will still produce lousy results. It's like giving a master chef poor ingredients. There is only so much they can do. By thoughtful you're setting your ML projects up for success and yourself up for acing the AWS specialty exam. So that was our feature engineering extravaganza for today. Drop your questions in the discussion forum, and remember, your models are only as good as the features you feed them. So until the next lecture, keep transforming that data.